Okay, so in this module, you learn about Ethernet. Ethernet, as you know, is a protocol or a technology, okay, which is primarily for LAN, local area network. Okay, so Ethernet mainly dictate how devices communicate with each other. So, so there are rules or Ethernet network, the rules of communication. For example, in the previous chapter, you learn every device has to sense the media before it sends the signal to the media. And if the media is busy, it waits a random period of time. So this is a rule, okay? So Ethernet uses CSMACD, and basically these rules or protocol makes a difference between different. So when you hear oh, DSL is faster than ADSL is faster than DSL, okay, which are also protocol, but they are for wide area network. So these rules or these protocol makes the difference uh, 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 how different devices communicate on the network. Okay, so Ethernet is one of the most widely used protocol in LAN, and also Ethernet also is used in kind of wide area network, this which is called MAN, municipal area network. So for example, Bell, so what they do is they're using Ethernet technology to set up a network in one area, for example in DDO. So the whole area is using Ethernet technology instead of wide area network technology, for example, frame relay, ATM. So it is because it's very fast. Okay. So for example, remember I told you if you have to connect to branches, you you call ISPs, and they're the one who will provide the physical connection. And usually it's wide area network technology like frame relay, ATM, ISD, and there are different technologies. But now, if the distance is not far, they can also use Ethernet to connect, let's say, depending on their setup, to connect, for example, our center, which is in Lachine, to the center in Verdun. Okay, probably because the distance is not that far. So maybe there's a network, Ethernet network. So the reason I'm explaining it to you because Ethernet is a local area technology, but now it's also being used as a limited wide area technology. All right, so Ethernet has frames, it builds frames, it combines all the information into a frame, information that is needed to communicate on the network, okay? Ethernet has sublayers, Ethernet uses MAC address, okay? What else? And then switch will cover the basic of switch, how switches forward packets, okay? So let's talk about Ethernet frames first. So Ethernet encapsulation. So first of all, Ethernet works with data link and physical layer. Okay, these two layers. Ethernet does not deal with network transport or any other layer. And it's the family of IEEE 802.2 and 802.3 standards. Okay, so when you're buying the device, well, let's say if you're responsible for purchasing the devices, make sure your device, so if you already have existing, let's say, switches, network cards, or even router with router interface, and so if you have existing devices, that's why standard is important. Okay, this 80.2 and 80.3, these numbers are important because if you have existing devices, make sure your new the new devices you are purchasing are compatible with your existing devices. Mostly they are. When there's a new standard and they make new devices, they also include the backward compatibility. But it's always it's important to look at the documents before you purchase. Look at read the specification that your devices are compatible. So Ethernet. So there was a little bit of discussion in the previous chapter about Ethernet sublayers. Okay, so Ethernet. Sorry, data link sublayers. So data link perform so many tasks in network communication that they divided data link layer into sublayers. Okay, to simplify the data link layer task. Now, what you need to know, okay, about these sublayers. Okay, first of all, they're called LLC sublayers and MAC sublayers. So LLC is mostly deals with the software or deals with the network layer, because if you can see here, data link layer just below network and just above. So well, it's in between network and physical layer. So to make it easier, think LLC deals with the network layer and MAC layer sublayer deals with the physical layer. Okay, deals or work with the physical layer. So LLC is mostly software, deals with the software, and it identifies which layer protocol is used for the frame. Okay, which layer, either it's TCP/IP version 6, version 4. MAC is responsible for encapsulating data, and also so it's responsible for encapsulating the packets. Encapsulation means like a capsule. You encapsulate all this information into one, either you call it frame or, well, they in Ethernet, they're called frames. So all this information is needed to access, to carry signals from source to destination. All this information is needed. Remember, I don't know if you guys still remember. Well, by the way, there's another lab in Wireshark. Okay, so you can see all this information: source address, destination IP address, source MAC address, destination MAC address. So these are the most important information. So they're all encapsulated, and it's the job of MAC sublayers. Okay, and also the MAC sublayers provide addressing, which is MAC address. Okay, now don't be overwhelmed with all this that is inside the frame. This is something you guys would need when you become more experienced in networking. Okay, to troubleshoot, monitor network problems, or even testing devices, hardware devices, or even software as well. So right now, just we're just what I need you to know, what is the purpose of this topic, is that all this information is encapsulated into frame, and all this information is needed in Ethernet network to carry signals. So as I said before, MAC sublayer is responsible for encapsulation, data encapsulation, and actually accessing the media, because it's directly connected uh, uh, to physical layer. And so what is encapsulation includes, what is encapsulation actually? So what is include? So it includes an Ethernet frame. This is the internal structure of the Ethernet frame. So this is the Ethernet frame. This is the structure. It has to follow the same structure. Okay. Now, remember I was telling you, you can use network monitoring software such as Wireshark to troubleshoot network problems. So how do you troubleshoot network problems? Okay, so if your network flow is down or whatever, one segment is not able to access the other segment, and you check IP addresses and all this is correct. So maybe the problem with the data link layer. So you use Wireshark to monitor capture network packets, and the structure is not the same. Okay, it does not follow the structure, meaning does not follow the rule of the frame. So that means there is a problem on the network, either is hardware related or the software related. Okay, so Ethernet frame is the internal structure. Okay, this is the internal structure of the frame. Ethernet addressing includes source and destination MAC address, and there has to be some kind of error detection. So that is also provided by, this is provided by sequence number, okay, for error detection. Okay, so every packet is the sequence. So if one packet is lost, how the Ethernet know to rebuild the whole communication stream is through sequence number. Okay, so the MAC sublayers is include a specification for different standards, like also it deals with the media, like what type of media is being used, either copper and fiber. These are the most common medias, and then you have wireless signals. Okay, uh, now Ethernet is the shared medium, meaning all the devices share the same medium. Okay, there's no dedicated line for each devices, so you have same cable or the switch that shared that devices use to send and receive signals. Okay, and because it's a shared medium, there is a possibility of collusion between signals. So to avoid this collusion, it uses a method called CSMA CD, which I explained in the previous chapter. Now, in the past, Ethernet uses hub, but now every single network uses switch. I don't think you will ever have to see hub again in your life. Nobody uses hub. I don't even know if they still make it. And again, we talk about the half duplex and full duplex in the previous chapter. So just the quick recall. So half duplex only only either a media device can only send or receive at a time. Okay, either send or receive at a time. And full duplex, both send and receive at the same time. Again, you won't see any half duplex device anymore. Okay, every single device from at least past 5-6 years are full duplex. All right, so let's see what's inside the Ethernet. What exactly Ethernet frame is, and how can you use this information to troubleshoot network problem, and why do you actually need this information? Okay, so first of all, so Ethernet has a minimum frame size and the maximum size. Minimum size and the maximum size. Why do you need to know? Minimum is 64, maximum is 1518. Again, Why you need to know this? You don't need to memorize, but you need to know the minimum and the maximum size. When there's a problem in the network, you're monitoring your network traffic, because this would be one of your tasks, to monitor network traffic. Believe it or not, in old days, and when I say old days, I'm talking about 5 years ago, okay, not 30 years ago, or so. In IT, 5 years is old. In old days, it was network engineer, network administrator who used to monitor network traffic. That was his job. Now, because of the cloud, more internet activities, more security threat. So the network engineers are probably, yeah, busy with managing cloud. Every company is using cloud. So the monitoring of the network is also, in many places, have become the task of tech support. Okay, so that's why things are getting more and more sophisticated for even entry level position. Okay, before, a tech support does not even have to deal with any type of networking. They were only responsible for operating system, desktop, and hardware. Okay, now, and there was a network technician, the network administrator, and the network engineer. But now, since networking has become such an integral part, so even in entry level job, you're required to know, to have networking knowledge. And plus, hardware hardly fail. Companies, actually, they lease computers from big company, mostly from Dell and IBM. Okay, so they lease computer for 2 to 3 years, and when they lease computer, it comes with full warranty. Even our school board, we lease computers for other department except computing support. Uh, we lease computer after the and it comes with the 3 year warranty. So if anything goes wrong with the hardware, they send the technician and they fix the hardware. They replace it. What do you mean? Well, they don't fix it, but they replace it. And after that, they just they lease other computers. So the hardware problem is rare. It's mostly the network problems. So let's get back to the topic here, why you need to know. So yeah, some of the students, they started their job is just to monitor network traffic, okay, right after their stage. So you don't have to wait a couple of years to do this. Probably in your first job, you have to monitor network traffic. Anyway, so what is network monitoring? So, for example, Ethernet. So the network is slow, network is down, people cannot access the network. So you did some obvious troubleshooting, IP address, whatever. Look at the server, and everything is fine. Then you have to start monitoring packets. So if you see the Ethernet size is less than 64 byte, because it tells you, so network monitoring tells you the size of the frame. If it's less than 64 byte, that means there's a hardware problem, most probably. And this has come with experience. So if I see a frame that is less than 64 bytes, I suspect a malfunctioning network card, uh, not properly terminated connector on the cable. Okay, a port on a switch could be a problem. It's mostly physical problem. Same thing if it's longer than 1518 bytes. So it's a problem. It should not be. Okay. So that also indicates a hardware problem. So you look at the source of the packet, where it's coming from, and then you determine which device is causing this problem. Okay, so that's what you have to know. So there are some the frames with more than 1500 bytes of data are considered jumbo or baby giant frames. Okay, so that means there is a problem. So these are the some terms. Runt frame is automatically so some frames, if there is a problem, they're automatically discarded, and some they're not. Okay. So what happen is when the frame is less than minimum or greater than the maximum, the receiving device drops the frame, and that can create the problems, keep dropping the frame on the network. Okay, so you have to fix it, this problem. So in the field, okay, you don't need to memorize this. You can also, when you're given this job to network traffic, then you can have like Google it, or use this PowerPoint and look at the frame types, okay, the bytes and the size or the length of each frame. Okay. All right, so you guys have already know what the MAC address is. I'm not gonna go over this. So MAC address is 48-bit binary value that is converted into hexadecimal, and you probably have seen MAC address many times. Okay, so that's all we need to know about the MAC address. What else? So this is how the Ethernet MAC addresses looks like. Okay, we don't you don't need to go into the detail. One of the thing you need to know is to, so the MAC addresses, can you imagine, MAC addresses has to be unique on every network card. So imagine how many billions, now there are billions in the network card. How so how IEE can ensure that every single MAC address is unique in the world is by assigning 6 hexadecimal OUI, organizationally unique identifier. So if you decide to open a company that manufacture network card, you would need to contact IEEE. They will give you this number, OUI, organizationally unique identifier, which is 24-bit or 3 bytes. Okay, and the rest you can use as you choose. So this is how each MAC address is unique on the network. Okay. All right. So the frame processing. So what is the job of Ethernet? Is to make sure the source and the source and the destination MAC address is included in the frame. Actually, you as a human identify devices either by name or the IP or by the IP address. Okay, but devices uses MAC addresses to identify devices. So when you're accessing a computer on a network, actually a MAC address is used to identify that computer, and then the MAC address is translated into IP address, which is the job of the protocol ARP, Address Resolution Protocol. I don't know if you guys still remember. So that's all you need to know. So there's a source address and there's a destination address. Okay. And MAC address. So the first time, I don't know if you guys have noticed, when you ping a device the very first time, the first ping is lost, and the next three pings are successfully sent to the device, received by the devices. It's because of the MAC address discovery. Okay, So because the first time your computer does not know the mapping, that this IP address that you ping is belong to what device. So it sends a discovery message on the network. Okay. So once it discover that device with attached to that IP address, MAC address, IP address is attached to that MAC address, it stores in it cache. Okay. And so for that reason, the next time you ping the device, it already knows that which IP address is belong to which MAC address, because it stores in the device. So what devices use MAC addresses? Any devices that uses that connects to the network using Ethernet. And what devices connects to the network using Ethernet? Printers, servers, your mobile devices uses Ethernet when they connect to the wireless network. Routers, router interface, Ethernet interface. Not all of them, but the Ethernet interfaces, they uses MAC address. All right, a unicast MAC address is so there are three types of MAC addresses: unicast MAC address, broadcast, and multicast communication. Okay, so there are three type of communication. Unicast, what you need to know is just point to point from one computer to another computer. Okay, that's the unicast. Okay. Broadcast is from one computer to all the computers on the network. Broadcast is not good. Okay, that's why we need devices to minimize the broadcast. That's one of the reason we need to segment the network to minimize, to contain the broadcast. So the broadcast MAC address includes all FFFF. Okay. Now, why you need to know the broadcast address? So again, your network is slow, your network is down, you don't know what's going on. You monitor start monitoring your network traffic, and you see a lot of broadcast frames with all FFF. Bad sign. Broadcast frame can it's not just they indicates a hardware problem, can they can also indicate software problem. Okay, they can also indicate an attack on your network. Somebody install a software on your network that is keep sending broadcasts to bring down your network. Okay, so the broadcast is not good. Okay, and that's why you have routers and switches to minimize the broadcast or contain the broadcast. Multicast address is from one to the group of computer. Okay, so it's like mostly used, not all the computer, but the group of computer, mostly used in gaming. Okay, where a host need to access the group of devices. Okay. All right, so you guys have probably know what a switch is, what switch does. Am I right? Have you guys learned about the switches before?
Yes.
All right. So again, so I'm just going to be very quick. So so switch stores MAC addresses of all the devices on the network, and based on MAC addresses, they forward packets. Okay. So, and how the switch So that's why switches are more efficient than hub. Hub, they used to they because they did not use MAC addresses. So they, whenever they receive the packet, they broadcast the packet to the whole network. And I just explained broadcast is bad. That's why switches are obsolete. Even if you use a switch, the network will not last, okay, more than an hour these days. Okay, so the switches use MAC addresses. How switches learn the MAC addresses? Anybody? So Masood, do you know how switches learn the MAC addresses?
Mm, when it's connected to the Ethernet, it saved the MAC address for the system.
Okay, so well, of course they're connected to the device. So MAC addresses are learned by the switch whenever you connect a device to the switch, and the device initiates network connection. So the first time, MAC address does not know where to send the packet because it does not have the list of all the MAC addresses, okay, in its MAC address table. So when the first time device connects to the switch and it initiates the net, well, is trying to access any other network, the switch stores the MAC address of the source in its table. So one by one, this is how switch learns the MAC address of all the devices. So so in the beginning, switches, they forward broadcast to all the ports. Okay, that's why switch cannot stop the broadcast. They can minimize the broadcast, but they cannot stop because in order to learn all the MAC addresses, they have to send the broadcast. So in the beginning, this is how switches learn the MAC addresses. Okay, and then they create the MAC address table in its memory. So this is these two slides. I just explain it. Okay, that they build a table, they learn the MAC addresses in its and then after they filter frames, okay, as a switch receives frame from different devices, it's also populates MAC address table. Okay, so it MAC address table populates once it learns all the MAC addresses. So we have one, let's say we have these four ports connected to four devices, and the switch learn all the MAC addresses and it just forwards to that device. So if computer A is accessing computer PCA is accessing PCD, switch receives the packet and it knows, okay, the 000D is belong to PCD, and it sends the packet to PCD. It does not send the packet to other ports. Okay, so this is what frame filtering is. This is how switch is more efficient than hub. So I suggest you, when you're reading, okay, your curriculum, watch this video. It explains the MAC address on connected switches. So it's more animated. And they're sending the frame to the default gateway. Switch speeds and forwarding method. So speed of the switch is important. So you have 1 gigabit port, 10 gigabit. I don't know what is the maximum right now because it keeps changing. It's probably 20 gigabit. So the so there are different forwarding method the switches use. One of the forwarding method is called store and forward switching. This method receives the entire frame, okay, the whole frame before it forwards. Okay, so this forwarding method is little bit slower, but it is more reliable. If there's an error in the frame, it can detect before it forwards the whole frame. So the speed over reliability. The other method is cut through switching. This is the frame is forwarded before it entirely received. Okay, at the minimum, it needs the destination address of the frame to forward. So this is less. The reliability is compromised on speed. So it's much it's faster than store and forward, but it's more less reliable. Okay, and so obviously the big advantage of store and forward is it can determine if the frame has errors. Okay, and store and forward also switching is also required quality of service. Okay, a quality of service is when you have a network that also using voice over IP. Okay, so you have to prioritize which traffic have the priority, voice traffic or the data traffic, and mostly is the voice traffic. Anyway, we'll talk about QoS later. Okay, so there's a cut through switching again. It So it sends the packet or the frame as soon as it receives the destination address. Okay, and the cut through is also, there are two variants of cut through switching: fast forward switching and fragment free switching. It's fast forward is uses the lowest level of latency, meaning it's the fastest. Okay, as the name implies. And fragment free is provide high level of latency, but also more integrity, meaning more correction. But anyway, as so these are type of switching that is being used as a network engineer or professional, whatever. You don't get to decide, I'm going to use there's no option where you use fast forward switching or fragment free switching on a switch. It's just when you buy the device, it comes with either fast forward switching or fragment free switching, so you have to decide which switch you want to buy, but mostly it's the fast forward switching. So as you guys you guys know what a memory buffer is. Okay, it's a part of memory that is used for fast access. So switches also have memory buffer. Okay, where the frames are stored for switching. Okay, so we already talked about full duplex, half duplex. I don't know if you're unlucky to find an employment where they're still using half duplex switches with full duplex switch. So you have to match the setting with software. So when you configuring the command switch, you also have to configure the full duplex or half duplex. Like I said, most switches, at least 5-6 years old switches, use full duplex, and companies they change switches after 2-3 years or 4 years. So it's highly unlikely that there are companies still using 6 or 7 year old switches. Even our school board replace switches after 3-4 years, and we are a public organization. Okay, where we don't like spend a lot of money on IT compared to private organization. So yeah, you don't have to change full duplex or half duplex setting on a switch, but just in case if you encounter a device that is still using half duplex, there might be a button where you can change the setting. And by the way, gigabit Ethernet only operates in full duplex. So even our school retired 1 gigabit switches and they replaced to 10 gigabit. So I cannot imagine any organization is still using 100 megabit per second switches. So I know so a lot of slides are dedicated to duplex and speed setting. So here it's a feature in the switch where you can issue a command to either use full duplex or the half duplex. Why you have to change it? Because if one device is using full duplex and the other is half duplex, the device that is using full duplex need to be demoted to half duplex. Again, probably you will never have to see it. If anybody's seen it, please email me and tell me, okay, sir, you told me I don't have to see half duplex device, but here they're only using half duplex. That would be interesting. Auto MDIX, I already explained it in previous chapter when we were talking about physical layers. So auto IMDX is a feature where your device, in this case, a switch, automatically detects it's either the same device or the different device. So you don't need to use either crossover or uh, uh, what is the other one? Straight through cable. Okay. So even if you're using straight through cable with similar devices, if there's a auto MDX feature in the software, it will automatically detect. Okay. Well, it has to be embedded in the iOS. In our lab, some switches has the auto MDX and some switches don't. So for that reason, you have to use a crossover cable. Okay, so that is the end of module 7. Okay.